Hello everyone, myself Dr. Jyoti Mandala. Welcome you all to the video lecture series on object-oriented programming through Java. We are in our lecture number 12. So we are going to learn in this lecture about two-dimensional arrays. Actually, in the last lecture, we learned about what is nothing but an array. And we have learned like the Java array is nothing but an object which contains elements of similar data type. So we have already learned in the previous lecture why we need to go to the arrays concept, because if you want to have an option of storing more than one value with a single variable name, that can be done by using your arrays concept. So in Java, array is also considered as an object where by using this array we can store multiple elements and all the elements should be of same data type. Now we also learned like all the values whatever we are going to store in an array, that will be stored in continuous memory locations. So if you want to store some amount of data with the same variable name, that much of sufficient amount of memory should be available continuously so that it can allocate, so that it can store the data continuously. Right? So normally we learn like it is a three-step process where we need to follow the declaration of an array and then instantiating the array, which is nothing but allocating the memory, and then initialization of an array. So these things we already learned, and we have three types of arrays: one-dimensional array, two-dimensional array, and three-dimensional array. So in the last lecture, whatever we have learned is about one-dimensional array. Like we have covered the three-step process of declaration, instantiating, and initialization, and whatever is explained there, that is about one-dimensional array. For your reference, I'll give a quick review of one-dimensional array, but if you want to learn in detail about one-dimensional array, you can get the data from this link. That the link will be provided here. Right, so we have here I am showing the combined approach of declaration and instantiating. That means I am declaring and allocating the memory in one step. We all know like allocating memory can be done by using new operator. Right, so you need to specify the data type, you need to specify the array name. As it is a one-dimensional array, we need to specify one dimension only, and then we need to use a new operator to allocate the memory, and whatever data type we mentioned here, that should be specified here. And here in this dimension, you need to specify the size, saying like that many number of values you want to store into that variable. So here is a simple example. I want to store 5 roll numbers. So I have taken a variable name as roll number, and I have given a value of 5. So 5 values can be stored in the roll number variable, and memory will be allocated accordingly depending upon the data type. The memory will be allocated because we have used the new operator. Right, so you can see the memory allocation will be done as I have given 5. So 5 blocks of memory will be allocated, and that will be given an index starting from 0 to the size -1, whatever size you have given. In the last lecture we have already learned these things. Always the indexing will start from 0 to 5, that means size -1. In this example 0 to 4, and this will be the first location will be pointed by the roll number. Right, so these things we already learned. And if you want to initialize the values can be initialized simply by giving all the values between these two flower braces. So in this case, no need to mention the size. So how many values you give, that much of memory will be allocated automatically. Okay, so if you are combining the declaration and initialization at once, no need to mention the new operator. Right, this is a simple example where I have given the 5 values directly without giving any size in this brackets. Unlike your C programming language, in Java, no need to mention the size here. Right, or else we can you can assign the values at the runtime also. This is in the program we are mentioning, or else we can assign the values at runtime by using our scanner class. So how to do all these things we have learned in our last class. Right, so let us jump to the second type of array, that is our two-dimensional array. Now coming to the two-dimensional array, as the name itself is specifying, we need to have 2 dimensions. Now this is also used to store more than one value, but what is the difference between one-dimensional and two-dimensional? In one-dimensional we will be storing only one dimension of values, that means only one row of values. But if you want to have an opportunity of storing multiple rows of values, then we can go with the two-dimensional array where we can store the data in the form of matrix and table. You all know what do you mean by a matrix. Matrix is nothing but, suppose if you want to have if you have only one row like this, let us consider. If you have only one row like this and you are storing more three values, that is considered, then this is called as a one dimensional array. But suppose if you want to have an option of multiple rows like this, you want to have multiple rows like this, and then in such a case you need to go with a two-dimensional array where each row is capable of storing the values. So in the second row also you will be storing three values, and in the third row also you will be storing the three values. So if you see this one, this will be looking like a table. So if you want to store a data in the form of a matrix or a table, then you can go with a two-dimensional array. Right? Now, how the declaration can be done? The declaration can be done by simply the way you have done for the one-dimensional array, which allows us to specify the array name and the data type, and also we need to specify two dimensions here, empty dimensions. No need to mention any row size and column size. Just specify the data type, array name, and provide two empty brackets. If it is only declaration, provide two brackets. Right? So here is an example. I want to have an array A where array A is now two dimensions. So that's why I have provided two brackets, and all the values should be of integer data like that I am specified. Okay, so now coming to the instantiating. Instantiation is nothing but we want to allocate the memory to this array A. So to do that task, we need to use the new operator. And how that can be done? Once the declaration is done like this, using the same variable name, you need to specify that variable name and use the new operator and type the same data type, whatever you have written here, use the data type, and then write down the row size and column size. Row size specifies the number of rows you want to have in your you want to have, and column size specifies like each row how many values it can store. That is about column size. If you see a simple example here, I have declared a variable A as two-dimensional array. Now here I am specifying the size, and also I want to allocate the memory using the new operator. You can see here three rows I want to have. So row 1, okay, let me draw here row 1, okay, row 2, and row 3, and three rows will be capable of storing, each row is capable of storing 4 values. So you can store values like this. So 1, 2, 3, 4, 1, 2, 3, 4. So a total of 12 values are possible. Or else you can combine the declaration and instantiating as one statement like this. If you can see here what we have done. Data type, array name. We have not specified any size here. We have simply told like it is a two-dimensional array, and we have written new data type and then row size and column size. Here is the example. These two statements are combined like this. So you can go individually like declaration initialization or instantiation, or else you can combine the declaration instantiation like this. Got it? So if you see the memory allocation, how it will be done. Suppose you have declared like this. We are taking the same old example. Okay. Now you have declared like this. Now once the declaration is done like this, now what happens? 3 rows, and that means first row will be created. First row is capable of storing 4 values. Why? Because we told the column as 4. Next row is created. Again, it is capable of storing 4 values. Third row is created. Again, it is capable of storing 4 values. Right? Now, how the indexing will be given? The indexing will be given like each row will be given a value of 0, 1, 2, 3. That means always the indexing will start from 0, and we have 3 rows. So 0 to 3 minus 1, that is 2. And each column is also given an index, and the column is also starting with an index of 0 to column value minus 1, that is 4 minus 1 is 3. Now, how the individual value can be accessed? If you want to access this value, how that can be done? If you want to access this value, how that can be done? That can be simply done by giving the array name and give the row index and column index. That means, suppose if you want to access this value, first value, then you need to write A of what is the row value 0 and the column value is 0. Suppose if you want to access the second element, this will be your second element. Second element will be accessed by using the array name. Row index. We need to specify the row index. Row index is 0 and column index is 1. Third element will be accessed like A of 0, 2. Right? And the 12th element, this one will be accessed by using row index is 2 and column index is 3. So that means we need to access the values by specifying the row size and column size. Right? This is how memory will be allocated. Now coming to the initialization. Initialization is nothing but once you have allocated once you have told what is the data type, what type of data you want to store, and what is the array name also you told, and what is the row size and column size also you told, and you have allocated that much of memory. After that, you want to store data into that array. Now that can be done by using your initialization. Now initialization can be done in two ways. One way is by assigning the values directly into an array, that is nothing but your compile time initialization, or else you can assign the values at runtime, where you can ask the user to enter the values. So let us see both the things. First way is assigning the values, that means at the compile time. That means in the program itself we are giving what actually the values is. That means the values whatever you are giving to the program that are fixed, the number of time you are executing. Suppose for the first time you are executing, the values are same, and second time if you are executing the same program, the values will be same. So if you want to have such an option, then we can go with the compile time. So how can we assign values at the compile time? You can assign the values at compile time in two ways. First way is assigning individual array elements. So that can be done by writing the array name. You need to specify the row index and column index and give whatever value you want to assign. Here is a simple example. I have declared and instantiated the memory like that. So A is capable of storing 12 elements. Now if you want to assign individual array elements in the program itself, then you can write A of 00 is 10, A of 01 is 20, like that. You can simply specify the statements. Okay, so you can initialize individual value elements like this. This is one approach. But what is the problem with this one is, suppose if you see this statement, 3 rows, each is capable of storing 4 elements is nothing but 12 elements. So we need to write 12 statements to assign the values. Suppose it is of array size of 10 by 10, then we need to write 100 statements, which is a very big task. So to reduce this work, what we can do is we can combine the declaration initialization like this, where what are all the values you want to do, that can be simply specified as a list in one single line, which are separated by a comma, and all the values should be kept in between the flower braces like this. So here is an example. I am declaring int A of 3, 2, and I am not using any new operator. Simply I have mentioned all the values. 632 is 6 values I have mentioned directly. Earlier slide we learned that individual values can be assigned, but what is the problem there is, we need to write that many number of statements, individual statements. Suppose if this approach is not there, you want to store 6 values, means 6 statements need to be written. But here you can specify all 6 values in a single statement, separated by comma and kept in between the flower braces. So you need to observe here is no need to use the new operator. The memory will be allocated accordingly, automatically, depending upon the number of elements you have given here. Okay. Now here if you have given like this, let us see if you have given values like this, that means a group of two elements will be created like this, and this will be considered as first row, and this will be considered as second row, and this will be considered as third row. That the compiler will come to understanding according to your column size. Got it? Or else you can make it more clear like this, where individual row values can be again grouped together in between the flower braces. If you write like this also, it will be more clear for us. But even if you write like this or like this, the compiler will not get confused. But for our understanding, we can place the row wise values in between the flower braces like this. Now what happens? A of 00 is nothing but this 10, that will be allocated first, and then the second value whatever we have, that will be taken as the second value. That means 20 value, which is stored at A of 01. That means that these two will be belonging to row 0. And this row will be having a column value 0 and column value 1. This is a row 1, and again this is having a value of column 0 and column 1. This is row 2, and again this is having a value of column 0 and column 1. Now coming to the next value, which is 54, which will be stored at A of 10. So that means it will be stored here. And A of next value is 66, that will be stored at A of 11. According to the size, whatever we have mentioned here, that will be considering, that will be stored accordingly. Next two values 12 and 77 will be stored like this. Now what you can understand from this memory allocation or from this initialization is, always the values will be stored row by row. That means after storing the first row only, it will go to the next row. The values will not be stored column by column. 10, 20, 54 are not stored like this. The values will be stored row by row. Once first row is filled, then only it will go to the second row. So you need to remember this point, all of you. Values will be stored row by row. So this is how data will be stored at compile time. That means in the program itself we are specifying the values, and these values are fixed for this array A, and if you are executing for more than one time, the same values will be initialized. But if you want to have an option of giving different values for different times of execution, then we need to go with the second type of initialization of an array, that is about runtime initialization. So with this approach, we can have an option of giving different values at different times of execution. Okay, that means in the program we are not specifying the values. At the time of executing the program, we will be giving the values. Now to do that one, we need to use the scanner class. What actually this scanner class is already we learned in the last class. This scanner class is used like a scanf statement in your C programming language. So here we need to everything is in Java, everything is like a class. So we need to use a scanner class, and it is the code for this scanner class is defined in java.util.star package. We need to import this package. Okay, now the code for this one is we need to first we need to declare the array, and we need to allocate the memory. This statement we need to write. After that, scanner class object has to be created, and using this object we need to store the values. So why I am writing two for loops? Because we need to read the values row by row. So for the how many rows we have? 3 rows. Observe carefully, we have 3 rows. I'll explain clearly. Follow all of you. How many rows? We have 3 rows, and each row is capable of storing 2 values. So let us consider the row value is 0, 1, 2, and the row value will be initialized by I. Let us consider. Okay, and j value is 0, 1, and it is pointed by the j. Let us consider. Now for I equal to 0 and I less than 3, isn't it or not? So 0 to 2, we need to repeat this step, whatever we are going to do. And for I equal to 0, we need to repeat the same step of asking the value for 2 times. That means the j value will be from 0 to 2. That's why I kept this loop here from in between these two. And what we want to do, if j value equal to 0, we need to read the value. You already know what is next int. You will be reading the integer value. Why? Because we have declared here int. Okay, next int, and that method should be called by using your scanner object, scanner class object. That is our S in our example. So the first value, whatever you give, that will be stored here, and the next time it will be iterated. That means j value will be 1. So j value will be 1 is nothing but we are here now. Still we are in our I equal to 0 only. So whatever value you give, that will be stored here. Now j value will be again incremented, which is 2 now. So the condition is fair, it will come here, and again it will after this it will again go back here, and I value will be incremented. Now I will be pointing to this one. Now again this will be repeated for j equal to 0 and j equal to 1, and again I value will be incremented. It will be repeated for j equal to 0 and j equal to 1. So row by row we need to read the value. That's why the logic has been written like this. Okay, so if you want to print the values, for printing the values, the thing is very simple. Again, we need to repeat the loop, and simply in place of this statement, we need to write system.out.println. We need to print a of ij value. Okay, so to understand this one, let us write down the code for this one, and let us see how this will be working. Okay, so if you can see. So what is the first thing we need to do is, we need to import, or else before importing anything, let us write our class. Our class is, let us consider 2D. Let us consider our class name is 2D. Because we are talking about 2-dimensional arrays. Okay, now we need to write public class, public static void main. Okay, our main method I am writing. And in this we need to write string args. And in the main method, I will be creating one array. How to declare an array and all, you all know. I'll be showing here how to declare an array. This is the statement we need to write. So let us consider an integer array only. Okay, and equal to new, because we want to allocate the memory also, and we want to store 6 values. Let us consider. So let me do 3 rows. Okay, now after this what we need to do, let us create one scanner class object. Okay, equal to new scanner system.in. So after writing like this, we want to, whenever you want to use the scanner class, you need to import a package called java.scanner. util dot start. I hope you all are clear with this one. Now, after writing the scanner class, you want to read the values at the runtime, or else if you don't want to read the user if you don't want to read the values from the user, no need of the scanner class. Simply I'll cut this one. What you can do is you can initialize the values like this: a of 0 0. Sorry, this is a of 0 0 equal to 12, and then this is a of 0 0. Okay, and then you can assign a of 0 1 equal to 22. Like that you can initialize the values. But here what we observed is, if you initialize the values like this, it is a time taking process where we need to write 6 statements. So let us first write. Shall we write like that first? Okay, let us write like that first. All the values let us write. Okay, so what is the next one? Yeah, only two values for the first row. Second one is a of 1 0 is 31. I'm taking a random values, so there is no logic in taking those values. Just a random value I'm taking. Okay, and then 32 I'm considering, and then a of next one is 2 0, and here I'm taking a value of 5, and then a of 2 1. So total of how, I think this is 1, right? Yeah. So total of how many values we are storing? 6 values, because we have given a size of 3 rows, 2 columns. So we have stored at the compile time. That means in the program itself we have given the values. So to print the values, what we need to do? We need to just write down the two printf statements, or else what we'll do is, let us write one output statement, out dot println values are. Okay, now I want to print the values. To print the values, what we need to do, I already told you, we need to use 2 for loops. You can check here, we need to use 2 for loops, isn't it or not? We need to use 2 for loops. So let us write down the 2 for loops. For, I think we need to declare the I value. So I will be declaring here I equal to 0, I less than, what is the size? 3, I plus plus. Okay, and then we need to write for in j equal to 0, j less than 2. Are you understanding, all of you? J plus plus. Okay, and then simply what can we do? We need to write system dot out dot println. What you need to do? A of ij. Just I want to print the values of a of ij. That's it. Because we have already assigned the values, I just want to print the values. Okay. So this is the end of the for loop. This is the end of the I for loop, and this is the end of your main method, and this is the end of your class. Now what we need to do? We need to first save this program. So our file name should be equal to your class name. If any syntactical errors are there, that will be displayed at the time of compiling your program. Let us save this program. So where I want to save this program is, I want to save this program in C drive. Okay. Here I want to save .java, and don't forget to change this one to all files. Okay, save. Now this is done. Let us move to our command prompt. Where is our command prompt? This is our command prompt. You all know we need to move to the path where our program is saved. I have saved my program here. Now I need to write a command called javac. What is my file name? I think the file name is 2d.java, right? Yeah. 2d.java, right? So if any error is there, that will be displayed here. Yeah, we got one error. What is that? I think I have kept a semicolon here. You can see here, I have kept a semicolon. There should not be any semicolon. Okay, now let us run this program, compile this program one more time. Again, I got the error. It's okay. I have not saved this one. Sorry. You can check here, there are no errors. I'll clear this screen once. So you can check here, there are no errors. So if no error is there, we can run this program Java. What is our file name? 2D. So we are expecting our output like individual values we are getting. So one more time, if you run this program, compile this program, and if you check the output, again we are getting the same values. So the number of times you run this program, we are getting the same values. But if you want to have an option of giving different values and getting different output, then we need to go with our compile time initialization. What is that compile time initialization? I'll tell you. Now remember, we can assign the values like this, or else we can assign the values like this also, where in the brackets we can give the values and we can print. Okay, that is one way of writing the compile time initialization. Now, if you want to have an option of having different values at different times of execution, we can go with the runtime initialization. To do that task, we need to use our scanner class, right? So, how can we do that one? Scanner, yes, equal to new scanner system.in. We need to use this scanner object, and I will be asking the user to enter the values. So what I will be doing is I'll be asking the user enter values, because enter 6 values. Just for our understanding, I'm writing this one. Okay, enter 6 values. Now after that, I need to repeat the statement 6 times to read the values. So how to repeat that one? Again, int. Sorry, let me copy the same thing. Okay, what I need to do here is I need to write. I need to store the value in a of I z, where it can be read by using next int. That's it. Very simple. Okay. Now you are reading the values and you are trying to print the values. So let us save this one. I'm overwriting the same old program. Let us compile this program. Okay. So any errors are there, that will be displayed. So no errors are there. Let us run this program. So it will be asking us to give values, 6 values. So you can see all the values are displayed as it is. So if you run this program one more time, that means if you compile this program one more time and run this program one more time, it is asking a new set of values. So we can give new set of values. Okay, you are getting those values. So this is how compile time and at runtime, 2-dimensional values can be accessed. Right? So this is how 2-dimensional arrays can be used in our Java program. It is allowing us to store a table of values. So using these 2-dimensional arrays, you can read two matrices values, and you can perform applications of matrix addition, matrix multiplication, whatever you have learned in a C programming language, same thing can be applied here. Just practice all of you how you can do matrix addition, matrix multiplication using these 2-dimensional arrays. So you need to write a Java program for that. I hope you all are clear with this concept. Let us all meet in our next lecture. So in the next lecture, we'll be learning about our multi-dimensional arrays and jagged arrays. Okay, so let us all meet in our next lecture. Until then, thank you all of you.